Number 6 of cycle 2, which is the experiment second one. So in this we are measuring directivity, half power beam width and gain of horn antenna. So in the given setup, what you have to do is first you connect the detector mount and connect it to the oscilloscope. Then in the setup, in the input, keep the Rippler voltage maximum, beam voltage minimum, and then come to the current. Keep the current from here, you'll move and you'll keep it at 15 milliamp. Keep this on, okay, when you're doing this one. Then after this step, now the Rippler voltage is maximum. No, come to the Rippler voltage in this. Now I'll slowly decrease this. Then in the output, you have to see when you'll be getting a square wave of maximum output. So now by varying this voltage, Rippler voltage, at some particular point you'll be getting a maximum VPP value. So stop the Rippler voltage at this point. Yeah, we'll stop here. Then after stopping there, come to this frequency meter. So in this frequency meter, you have to vary this frequency meter in such a way that you'll be getting some sort of a distortion at some particular frequency. So by moving this, so the distortion should happen over here at this particular frequency. The distortion happens. So measure the frequency, this bottom, okay, the bottom silver or this copper line. So it will be like nearly 9.426. So this is your operating frequency EF. So now we have got EF, operating frequency F. From substitute this F, okay, calculate lambda. Then from lambda you substitute in this S formula. S is distance of separation. So lambda value we got. Now what is D? D is this particular distance of the horn antenna. This is fixed, okay, 10 centimeter. Take it as 0.1 meter. Substitute here, you will be getting the value nearly 63 centimeter. Then disconnect this tunable short, fix the horn antenna in this form for E plane. This is the first step. My bad, this is H plane. After measuring the distances with the help of a scale, just ensure that the distance between the source and this load with this help of a scale should be more than the calculated value. It should be like more than 63 centimeter approx. Then connect the receiving horn antenna over here with the detector mount. Come to the output part. So next what you have to do is you have to set this at 0 degree. So here you set it at 0 degree. When you set that, ensure that this one, the load is almost straight to the source, and take the VPP reading. Now we have connected in channel 2, so we'll take the channel 2 as 0.2 volt into this VPP value. That is the first reading which we'll take, okay. So for this 0, in clockwise and anti-clockwise you'll be getting the same value, which is the maximum value, okay. Then after that what you have to do is in this rotate with the help of this, so that it will go to 5 degree, basically 355 degree. There will be 5 degree clockwise. Again measure VPP. Then again come here, increase this by turning this in the same clockwise direction. Come to 350, okay, 350 degrees, which is basically 10 degrees. At 10 degrees again come, only clockwise we are doing first, okay. Take the VPP reading, okay, you'll be getting a particular reading. So after taking the readings of clockwise, come back again to 0. After coming to 0, now rotate this anti-clockwise, okay. In anti-clockwise you'll be getting 5, then 10 and so on. So in anti-clockwise readings you'll be getting the same, okay. In the same way you have to take the VPP reading for the whole experiment. Basically with this you'll be getting the first part, which is basically the H plane. So for the second part, what you have to do is remove this horn antenna, fix this extension thing. Then you'll be getting the horn antenna in a square, in a rectangle form in vertical shape. Now that is for E plane. Now the same way in the receiving side you have to keep the horn antenna in this form, okay. Even in the source it will be in this form, even in the load it will be in this form, and repeat the same procedure. 0 degree, take the clockwise reading, It will be same for anti-clockwise. Then go in clockwise direction, you'll be getting the output reading. Similarly in anti-clockwise, you'll be getting the output readings. So E max is there, no? The E max is basically the 0 degree value. E5 is the values what and all we'll get here. Okay, and EM, which is maximum, is basically E transmitted, E suffix T, that is the same value at 0 degree. So then you have to calculate this. So at the end of the day, when you're doing the calculations, just ensure that your gain value, obtained gain, is less than the directivity value.